Over 10.3 million tons of wheat are harvested annually in Kansas, enough to produce bread for over 300 million people. The vineyards in Bordeaux. Meanwhile, Queensland processes more than 50,000 tons of shrimp a year, a weight comparable to 100 Boeing 747 airplanes. So just how do they outcompete other countries? The answer lies in the synergy between technology and humanity, which is how many industries are being redefined on Earth as it becomes home to nearly 10 billion people by 2050. When it comes to wheat, no place in the world has tons of wheat annually, accounting for nearly 20% of the total US output. The combine harvester is a versatile piece of equipment. It is the star of the vast wheat fields of Kansas. This machine performs three crucial tasks simultaneously: cutting, threshing, and separating wheat grains from the stalk. With a capacity of 25 tons per hour, one combine harvester can cover 20 acres in a single morning, a productivity level that would take a team of 10 workers an entire week to achieve. On large farms, 2 to 3 combine harvesters are often operated simultaneously, enabling up to 11,000 acres to be harvested in a single day. While machines handle the heavy lifting, workers play an essential role in operating the harvesters, monitoring their performance through integrated control panels. Workers on farms and wheat mills in Kansas typically make around 18 exceptional productivity, but are also equipped with advanced technology like GPS systems and moisture sensors. These sensors measure grain moisture on the spot, helping workers decide which batches require drying first. Thanks to these technological aids, farmers reduce product loss by up to 15%, while increasing their market value of wheat exports. This is particularly crucial in an industry where product quality determines price and competitiveness in global markets. But its economic efficiency is undeniable. Large farms in Kansas typically recoup their investment within 2 to 3 seasons, thanks to operating costs that are 50% lower than manual labor. After the wheat is harvested, specialized trucks transport the grains to storage facilities or milling plants, where workers conduct a final quality check. Here, each batch is sorted and processed into raw materials for products like bread, pasta, and high-quality flour. The seamless coordination between technology and human effort not only allows Kansas to maintain its title as the wheat capital of America, but also ensures its products continue to dominate global markets. Leaving behind the endless wheat fields of Kansas, we arrive here. Sprawling vineyards not only create breathtaking scenery, but also play a crucial role in producing over 4.7 billion gallons of wine each year, accounting for 10% of the global supply. Trimming robots are an indispensable part of Bordeaux's vineyards. Designed with exceptional precision, these robots perform tasks such as trimming vines and removing unnecessary parts, allowing the plants to concentrate nutrients on the fruit. A single robot can trim up to 50,000 vines per day, 3 times faster than manual labor. Up to 15 robots simultaneously has become common practice, enabling hundreds of acres to be processed in just a few days. However, unlike machines that can handle most of the heavy lifting, the role of humans remains essential, particularly in inspection and selection tasks. During the harvest season, workers carefully inspect each grape cluster, removing any that do not meet the quality standards. This meticulous work requires experience and precision, as even a single unripe or damaged grape can affect the quality of an entire batch of wine. Once selected, the grapes are sorted by size and ripeness and then transported to wineries for fermentation and aging processes. Here, the fermentation and aging process is closely monitored to ensure every bottle carries the distinctive flavours of Bordeaux. A trimming robot in Bordeaux costs around $50,000, plus losses by 25%, while saving up to 40% in labour costs for large vineyards. Workers here earn $15 to $18 an hour, a significant figure in the agricultural sector of France. Although robots have transformed harvesting methods, human expertise and attention to detail remains a cornerstone of Bordeaux's world-class wines. Of Australia. Producing over 50,000 tonnes of shrimp annually, this figure is enough to serve approximately 1.6 billion shrimp meals, one for every person in the US, Canada, and Mexico combined. Shrimp in Queensland are raised in closed-loop industrial ponds, where conditions like salinity, temperature, and water quality are tightly controlled to maximize yield. At harvest time, thousands of pounds of shrimp are collected and transported to processing plants within hours. This ensures maximum freshness. This is where shrimp peeling robots, a revolutionary technology, come into play. These robots can process 150 pounds of shrimp per hour, equivalent to the weight of a professional rugby player. With 5 robots working on an 8-hour shift, a factory can process up to 6,000 pounds of shrimp in a single day, equivalent to the weight of a fully grown African elephant. Thanks to technological support, processing times have been cut from 48 to just 24. Delicate and precision-driven tasks. Workers in Queensland earn between $20 to $30 an hour, equating to a monthly income of $3,200 to $4,800 during peak seasons. Meanwhile, a shrimp peeling robot can cost around $75,000, equivalent to purchasing a high-end pickup truck, saving factories hundreds of thousands of dollars each year. From Queensland's industrial shrimp farms, our journey takes us to British Columbia, Canada, a powerhouse in North America's salmon production. With over 162,000 tonnes of salmon harvested annually, this is enough to provide every person in the US with just over 1 salmon meal per month. This isn't just a key economic driver, but a symbol of how advanced technology and skilled labour can redefine an industry. The salmon harvest season in British Columbia runs from May till October, a time when farms and processing plants operate at full capacity. Salmon are transported from farms to processing plants on the same day in order to preserve freshness. Here, filleting and bone removal robots are central to production processes. These robots can process 60 salmon per minute and can prepare enough salmon fillets to serve 10,000 meals in just an hour, the same number of diners as is in 100 mid-sized restaurants in the US. However, while robots excel in speed, human workers remain indispensable for tasks requiring precision and oversight. Workers ensure no small bones are left in the fillets after robotic processing, maintaining the high quality demanded by export markets.